remember, almost as if it were yesterday, growing up in Arm Prior. You couldn't ask for a better place. People really cared about each other. We had a pretty fair hockey team in those days. We used to go over to the Huyck plant and they'd give us pieces of felt to use for the shin pads. Son of a gun, we won the Valley Championship that year with those pads. My father always said that the Huyck plant was a real good citizen of the town.
Over the past 100 years, Huyck has pioneered many of the innovations in paper machine clothing and conducted much of the research which underlies today's performance products. Ongoing research, massive investment in state-of-the-art equipment, and a strong commitment to quality and service sustain Huyck's leadership in serving the paper industry.
Here at Huyck Canada, we like to think that we don't just provide machine clothing and service. We help make paper. This philosophy has resulted in a lot of innovation over the years, much more than many of our customers realize. Let me give you a few examples. Of course, Huyck invented the synthetic forming fabric, and many improved designs such as double and triple layer forming fabrics and the highly successful X-Pick concept. But similarly, in press felts, we were the first to introduce needle felts, 100% synthetic felts, and our new multiple base felts are the leading edge on tissue and third press news positions. It's a very special relationship. There really are few things that can improve a papermaker's bottom line more than the right clothing selection.
It's a fact that paper cannot be made without felts. A felt has many functions in the manufacture of paper. It cushions the sheet, it acts as a conveyor, it drives the undriven rolls, and of course, it must be able to handle high water volumes well enough and long enough to be economically viable. Huyck produces the modern needled felts required on today's paper machines. It may surprise you to learn that there are as many different felt styles as there are paper machine applications. Each press position requires a custom-designed felt. Felts differ in width and length, of course, but they differ in many other ways, too. For example, the surface finish on a felt for a newsprint machine differs greatly from the finish on a felt for a tissue machine. Factors like density, porosity, water carrying, and surface tension characteristics all vary depending on application.
Our relationship with the client starts with an on-site visit by our sales engineers. They talk with the customer and analyze his needs and requirements for a particular machine and a particular application.
Once the customer needs have been identified, our designers get to work. They use state-of-the-art computer-assisted design and engineering equipment, which includes high-speed motion recording equipment and vibration analysis instrumentation. For each and every felt, our designers and engineers consider the felt's ability to handle water volume and to resist compaction and plugging. Will this felt be reasonable to install? Should we use pin seaming? What about rapid startup? The design of each felt is backed by the experience and reputation of our designers who have been creating press felts for worldwide applications for more than 100 years. A prototype felt is constructed. The Huyck Development Needle Loom is a single module of a large production unit and thus will exactly reproduce manufacturing conditions. The prototype is examined and thoroughly tested. The uniformity of the felt across its entire surface is key to the quality of the final product and to trouble-free performance.
How do we get this uniformity and predictability? Sounds simple enough. Let's take a look at the manufacturing process of a modern needled felt.
Huyck was a pioneer in the development of all synthetic press felts. Working with our suppliers, we are continually developing new fibers and yarns which are stronger, more uniform, and more wear-resistant than ever before. All yarns, whether they are purchased or blended and spun at the plant, are tested for quality and treated to provide fast startup and to control friction and static electricity. Depending on design requirements, 2 or more yarns may be twisted into a 2, 3, or more plied yarn. Once the yarn has the desired physical properties, the filling yarn is ready to be arranged on a cop or bobbin for use in the loom shuttle. The warper transfers the yarn onto warp spools ready for lengthwise weaving. The control console monitors brake pressure, spool length, and warping speed to manufacturing standards. An absolutely constant tension in yarns is crucial to ensure an even weave in the base fabric. The weaving process starts with the installation of the warp beam. The ends from the warp spools are then drawn through appropriate heddles to generate a predetermined weave pattern. Ends are then drawn through a reed which keeps the ends in order and also serves to beat the picks, or filling yarn, into the fabric. Then, finally, the ends are tied together and drawn over the breast beam and through the take-up rolls. This whole process is very labor-intensive and can take skilled personnel several days to complete. It used to be that the base fabric was woven flat. The ends would then be painstakingly joined by hand. Now, most felts are woven as an endless loop. This loom is actually weaving 2 sides of the base fabric at the same time, one being a mirror image of the other. The beginning of a press felt is the base fabric. It consists of an endless woven cloth. Over the past few years, weaving technology has become more complex. We now use much larger computer-controlled looms to create multi-layered weaves designed to support high-press nip loads. The type of yarns and weave used in the base fabric directly affect water removal, compaction resistance, stability, and sheet finish under running loads in the press. Once the base fabric has been woven, it is cut off the loom and taken to the burling room. The fabric is put up on an inspection perch and burled. This simply means a meticulous inch-by-inch visual inspection to ensure that the cloth meets our very tight quality standards. The last step to prepare the fabric for needling is a heat treatment. Heat stabilizes the woven base and gives the fabric a size memory. The temperature is strictly controlled according to design. We have seen the process involved in creating a base fabric. Let's look at the parallel but separate process of bat making. Appropriate bulk fibers are weighed, blended, treated, and put through the carding machine. This equipment combs out the fibers so that they are aligned parallel to each other. This produces a web. Several layers of web are combined in a computerized process to produce the final bat. The bat determines the compressibility, air permeability, water carrying ability, and the finish of the felt. Needling is the process which marries the bat to the base fabric. First, the base fabric is loaded on the needling machine. The bat is then positioned on top of the base fabric. Thousands of specially designed needles are affixed on movable needle boards. Each needle has tiny barbs like upside-down fish hooks. As the needle boards descend, the little barbs carry fibers from the layer of bat through the base fabric. This is Huyck's newest multi-million-dollar computerized needling machine. What makes this machine unique is its ability to counter-needle, a revolutionary needling process which minimizes water carrying in felts and enhances its surface characteristics. Each felt is needled under tension according to a specific needling code. The depth of needle penetration and the number of penetrations per square centimeter is computer controlled. Once the bat is needled to the base fabric, the felt goes to the finishing machine. Here it is loaded on the dryer and stretched to a specified length. A final heat treatment will stabilize it. At this time, it may also be given chemical treatments. Under controlled tension, our sophisticated QA1 machine makes its final analysis. QA1 measures thousands of points on the felt for caliper, mass, and porosity. Our computer-integrated manufacturing has brought the felt to the last process. Before a felt is shipped to a customer, it is given a thorough final inspection. It must precisely meet all final product acceptance standards.
We have totally re-equipped our plants recently with many millions of capital investment dollars, and considering our heavy emphasis on research and development, we'll continue to plow this investment back into tomorrow's paper making. Our most valuable resource by far is our dedicated, enthusiastic group of Huyck Canada people here and around the world. We enjoy our work and take pride in sharing the results of our studies into the relationship of clothing to paper characteristics, the development of new paper quality tests, and technical publications. We at Huyck are truly committed to quality, service, and the next 100 years of paper making.